Good morning to everyone. Myself N.Kalpna. I am from G.k.jain Higher Secondary School, Royapuram. For more educational video, please subscribe our YouTube channel.
Today for the 12th standard I am going to explain the lesson is coordination chemistry and the topic is optical isomerism. In the last class we discussed about the isomerism as well as the types of isomerism. Isomerism means having the same molecular formula but differ in the chemical and the physical properties. Okay. Today we have discussed about the optical isomerism. In the optical isomerism it will be having the same chemical formula but differ in the sign of rotation and the plane polarized light. What is the meaning of plane polarized light? If you are taking as a normal light, it will be exhibit the rays which will be exhibit in all the direction. But when you consider as a plane polarized light, it will be exhibit in a single direction. Let you see if it is considered as a normal light, the rays will be exhibit in all the directions. But the same light which is been kept under the nickel prism, when you taking as a nickel prism which is been fall on the normal light, if it is polarized means it will be exhibit only in one directions only. And the directions also, if it is the rotation, based on the rotation also it will be having different name. One is clockwise direction. If the rotation will be exhibit in the right side, that will be as a clockwise direction. That rotation will be called it as a dextro-rotatory and it will be indicating in the letter of D. And next one, if it is rotate in the left side, that means anti-clockwise direction, it will be called it as a levo-rotatory and the sign and the letter which is being used for the levo-rotatory is small l. Usually in organic chemistry they are given the compound, under the compound they have been intimated with the letters D as well as L, either D or should be L. Then we can be understand the compound will be exhibit in the right side clockwise direction or the anti-clockwise direction. And next one, if it is rotated means what are all the conditions? All the compounds will not be exhibit in the polarization. It will not exhibit under the polarized light. There is a certain conditions will be there. First condition which will be a non-superimposable. What is the meaning of superimposable and non-superimposable? When you taking your hands, if you have see your hands will be there. If you have seen the images on the mirror, if you could having the same type means if you are placed like that, the thumb finger should be placed on the thumb one and the ring finger, little finger, ring finger, all the fingers should be placed on the same thing means it is called as is impossible. The same while if it is been opposite direction, the little finger on the right side, on the thumb finger, the ring finger on the index finger, the middle finger and all that should be not impossible means it is called as a non-superimposable. The compound which will exhibit the polarization means it is under the non-imposable. Non-imposable means it is not fixed properly. That is called as a non-imposable. Usually when you see your figure on the mirror, you can see the fleets which is been actually it has been on the left side, but if you see on the mirror it has been on the right side. So if you have placed over there, it has not been fixed properly. That is called as a non-imposable. So if the compound is non-imposable means it has been under the polarization. And second one is they should not have plane of symmetry. What is the meaning of plane of symmetry? If I am taking as a square, if I am split into two off, I can get the equal of proportion. Okay, so this is called as the plane of symmetry. If the compound will exhibit the plane of symmetry means it is not under the polarization. For example, if you taking the shape of amoeba, it is an irregular shape. If you have divided, we could not having the same shape on both the sides. We could not predict the same size or same shape. Okay, that is called as if the compound will exhibit these property, then only that compound only which exhibit the plane of polarization. So these are the very important one. When the compound which is been exhibit the plane of polarization means it will be having a two condition. One is a non-superimposable, otherwise called as a enantiomers, or that property will be called it as a chiral property, chirality. Non-superimposable means which is not fixed properly. And next one, it should not having the plane of symmetry. If you have cut down means it does not having the equal offs, that is called as it does not having the do not having the symmetry. Okay, let me take in the example of polarization. See, PtCl2En2, when I am just having the images, if the images when I am kept in the nearer to the mirror, the same equal will be, it will be reflect. But the one thing is, if I am having that image which is being kept over there, see here Cl will be there, here Cl will be there, here Cl will be there, here Cl will. In that compound Cl will be on the right side, in this compound Cl be in the left side. If you have placed this compound over here, it is not being superimposable, then these compound will exhibit the polarization. This is an example of polarization. So this is about the optical isomerism. Why it is called as an optical isomerism? Because it is exhibit about the light. We are learning about the light. That is why these compound will be called, this property will be called it as a optical isomerism. Then the next one is about the valence bond theory. In before the classes we discussed about the Werner's theory. He only given the first thesis theory about the coordination compound, but he does not explain a few reality. That means he does not explain about the magnetic property, he does not explain about the color of the compound, but it was explained by the valence bond theory. It was given by Linus Pauling. He has been framed here 10 important points, main features of these compounds, main features of this theory. Let's see one by one of these properties. First one, so we already know about that coordination compounds means which will be having a metal which is bonded to the ligand. There is a bond will be between the metal as well as the ligand. That bond is always been in the covalent bond, because it is a lone pair. If it is the sharing, that bond will become covalent bond only. That is about the first point in the valence bond theory. And second one, it is about the ligand. So it is always the ligands will be the donor atom. It will donate the electron. If it is donate means it obviously it will be having the lone pair electron itself. Then only it can able to donate the electrons, isn't it? So ligands, what is the nature of ligands? Donating the electron towards the central metal atom. When it has been possible only if it is having the lone pairs of electron. That is about the second point. Third point, okay, ligands are donating the electrons. Which will accept the electron? Metal atom will accept the electron. So if the metal atom ready to accept the electron means it will be having that vacant space. For example, if the coordination number of an atom is 6, in which basis we are finding the coordination number? Based on the number of ligands. So ligands have been donating 6 electrons towards the central metal atom. Obviously that metal atom will provide 6 empty space, vacant space to accepting the ligands. So metal should have that vacant orbital according to the number of ligands. And next one about the hybridizations. So the ligands have the capacity to hybridize. What is the meaning of hybridization? If the d orbitals is d10 means if you are filling all the electrons have been filled, then how can the metal provide the space? Here it will be in the empty space. It is joined together. It becomes sp3. So that is called as a hybridization. So how can we hybridize? Because we are accepting the ligands. That is why the remaining empty will be hybridized. It is under the process of hybridization. And next one, during the hybridization, it will be formed the pi bond. The metal and the ligands have become the hybridization. It will be under the hybridization means it will be formed the pi bond between them. And next one, hybridized orbitals are directional. So directional means it does not exhibit in whatever direction it wants, it does not been exhibit. It will be having some tendency to exhibit in certain direction. For example, it only decided the geometry of a compound. If 4 electrons or 4 ligands are present means it is the square planar or tetrahedral. If 6 means it is obviously it will be in the octahedral only. So based on the directional only it decided the geometry of the compound. And next one, it will be divided into 2 things. Inner orbital, that means it provided low spin. Outer orbital, high spin. Inner and outer orbital. For example, if you see, these d orbitals are completely filled. So if ligands are providing the electrons means it will be attached, it has been accepted by these only. So other than d orbital, so it will be the outer orbital. In some cases, if it is not having electron, if it is d orbitals are empty space. Okay, so if ligands are donating the electrons means which is also involved to accept the electron. If these cases means the electron, the vacant orbital is present in the d orbital means it is called as a outer orbital which is exhibit the high spin and the inner orbital which exhibit the low spin. And next one, paramagnetism, the magnetic property, paramagnetism as well as the diamagnetism. The paramagnetism and the diamagnetism based on the pair up of electron. If it is completely paired, there is no unpaired electrons means it is called as a diamagnetic in nature. If it is unpaired electrons are present means it is called as a paramagnetic. So based on the number of electrons, pairing of electrons, we decided the compound whether it will be in the paramagnetic or diamagnetic. And next one about the strong field. So the ligands also it will be having two kinds. One is a strong field ligands and the other one is a weak field ligand. In case if it is singly bonded, off-filled orbits will be there means if the ligands are strong field means it will be having the tendency to pair up itself. All should be paired one, it will be having the tendency to pair up itself. In case if it is a weak ligand means it does not pair up itself, it will be exhibit the unpaired electrons only. Okay, so this is about the strong field as well as the weak field ligand. And finally it will about the greater the overlapping ligands, greater the bond strength. How the bond strength based on the overlapping of ligands. So these are all the points about the valence bond theory. So in today's session we have discussed about the optical isomerism, condition for optical isomerism and example for optical isomerism. And next one about the valence bond theory. Why the valence bond theory have been arised? Because of the Bernoulli's theory it will be having some limitation. He is not explain about the color of the compound as well as the magnetic property of the compound, but here in the valence bond theory he has been explained about the color as well as the magnetic property of the compound. They are the 10 points which is exhibit the valence bond theory. Thank you.
Subscribe now and press the bell icon. Never miss an update.